Yeah.
Like sitting it out, and then I was like gonna go sit and on my phone until you answered, but I guess I will not sit on my phone. Okay,
Sorry.
I know it's okay because now I get this done faster, and then I
There
can
you go.
relax before work tomorrow.
Nice.
Okay, number one. This one I was comfortable with because of chemistry, so I felt good about it. But this one I just said, in a solid state, H2O molecules are in a crystalline structure which spaces the molecules far apart. When in liquid state, the molecules are fluid and much more compact. Thus, when ice melts, the molecules come closer together, which prevents overflow. Is that along the lines of what you said? I don't know if that's like the physics definition, but that's the chemistry definition. So,
Well, that's a more detailed definition than what I found.
okay, that's fine. We'll use mine. Okay, how did you do number two?
So for number two, um, what I did is first I converted the 20 liters into the what is it, like liters per meter, so you can get volume.
Yeah.
And then since we're already since we have to go to a table to figure out the density of gas,
Yeah.
so I found that, which is approximately 6.8 by 10 to the second.
Yeah.
And so um, I put the density of gas on one side while I put the volume and mass on the other, solving for the mass.
Mm-hmm.
So I solved for mass and I got 13.6 kilograms. And we add that to the 2.5 kilograms of the can to get
Mm-hmm.
16.11.
Yeah.
And from there, we can find, we're given the density of steel if on the table as well.
Yeah.
So we can find the volume of steel by pretty much doing the same thing since we have the mass but not the volume. And so by doing that, we find the volume, which is approximately 0.322 by 10 to the negative third.
Yeah.
And then the density of the system is the 16.1 over the 0.02.
I
So
got.
I got
Oh, yeah. Sorry. Keep going.
805 kilograms over meters cubed.
I got 790, but that might be because I wasn't super exact on my rounding.
Well, that's where I feel like it depends. Like yours,
Yeah.
it depends on how you did your numbers, and mine depends how I did my numbers because that's still
But
pretty close.
all of my other numbers were almost exactly the same. Because I had, well, I mean, I converted mine to grams for the mass, but I had 16,100 instead of 16,110 like you did. And then for the volume, I had 0.321 instead of 0.322. So I think it's
Okay.
really small differences.
Yeah. And I've noticed on many of the examples I've been able to find on the internet,
Mhm.
everyone has like those small differences.
Yeah. Well, I think a lot of times, especially I noticed with other units we've done, whenever there's gravity in the equation, I feel like everybody's different because everybody uses something else for gravity. Like we just do 9.8. Some people do like 9.81, 9.816. Like it's all a mess.
Yeah.
All right. So for 3, to get A, I multiplied the 8.5 centimeters by the 11 centimeters of sheet paper, which gave me 93.5 centimeters squared. And then I converted that to meters squared, which gave me 93.5 times 10 to the negative fourth. And then I used the equation force equals the PA. So then I multiplied, like you have to look up the value, but it's the 1.01 times 10 to the 5th by the 93.5 to the negative 4th. And that gave me 944.3 newtons. So I rounded to 944. And I said that they could withstand the force because there's an equal force exerted on the opposite side.
That's what I said.
Okay. All right.
And that's what I got.
I felt like, I don't know, because I got, it's like 944.3, and I automatically am like, so 945. And I'm like, no. But I really want to do it.
It's so tricky. I've seen people do that, even on the examples.
Yeah. I've made mistakes like that before. On accident. All right. How did you do number 4?
So for number 4, you have the F1 over the diameter 1 equals F2 over diameter 2.
Mm-hmm.
So I rearranged it. So I got, since we're trying to find the force of the first one, so F1 equals F2 times diameter 1 over diameter 2.
Yeah.
And from there, just plug in the numbers after you, oh yeah, I forgot. Diameter also equals pi r squared, or yeah. And so you have to solve for those. So the first one is basically pi.
Yeah.
And then the second one, I just left it as 144 pi. So the pi's cancel out when you plug them in.
Mm-hmm.
So you just get 19.6 times 10 to 10 cubed over 144. And you get 136.11 newtons. Or if,
I just did 136. But yeah.
yeah. I keep doing decimals because it always throws me off.
I know. I always feel bad whenever they look at my paperwork because I will write out every single decimal the calculator gives me. Because I don't want to miss one and throw up all my answers. All right. So for 5, I said, while in the water, the buoyant forces help decrease the weight of the marbles. And then the weight of everything in the tub is applied to the bottom of the tub. Yeah.
That's basically it. It's on the marbles a little bit more.
What did you say?
So the weight of the marbles is reduced by the buoyant force, but the bottom of the bathtub is outside of the liquid.
Mm-hmm.
So therefore, the bottom of the bathtub feels the downward force caused by the marbles.
Oh, okay.
Therefore, the downward force on the bottom of the bathtub will increase by the exact weight of the marbles.
Yeah, we're going to use your number 5.
Okay. Sounds good.
For 6, to get the mass of the water that she displaced, I just did the 62 minus the 0.085, which gave me 61.915 kilograms. And then for B, I used the equation, the P equals M over V, and rearranged it so I have V equals M over P. And then I substituted the M that I solved for an A, and then I used, like you have to look up the value,
Okay.
the 1 times 10 to the 3rd. And that gave me 0.0, oh, let me darken that decimal point, 0.061915 meters cubed. And then for C, I did P equals MV, or M over V. Let me fix that. And so that's the 62 divided by the V from part B. And that gave me 1.00137 times 10 to the 3rd kilograms per meter cubed. And then I added my 2 V's together to get the total with the 1.75 liters, the volume that they gave for part D. And so I got that my total volume is going to be 0.063665 meters cubed. I guess I should round that. So that would be 6.37 times 10 to the negative 2.
Yes. I left it as the decimal with the whole thing.
I'm just going to round it. I'm going to put it in the scientific notation so I can only get 2 decimals.
Okay.
All right. How did you do number 7?
So number 7, since it's just a factoring, I use the equation A1 B1 equals A2 B2,
That's what I.
where A2 is the 18 times the 0.4,
Mhm.
and then which gives you 7.2 centimeters squared. And then in the equation, it'd be 1 times V1 equals 7.2 times V2. So you rearrange it. So you get V2 divided by V1 equals 1 divided by 7.2.
Yeah.
And that will give you your factor of 0.139.
Yeah. Oh, yeah. I just didn't round mine because I just left out 13.88. But let me change that.
Yeah. I got that too, but I thought, okay, I'll try to be a
Yeah.
2 significant figures.
Yeah. Sometimes I forget to round everything. All right. For 8, so I used the equation for the Bernoulli's principle, which is the P1 equals 1/2 PV1 squared plus PGH1, which equals P2 plus 1.5 PV2 squared plus PGH2. And I said the increase in breeze increases the velocity, and then the increase in velocity causes a decrease in pressure, and that decrease in pressure causes air to rise up from the higher pressure areas to the areas of lower air pressure.
That's a lot better than mine,
Okay.
honestly.
You can use this page for me then.
Yeah.
All right. And then how did you do? That was number 8, right? Yeah.
That was number 8.
How did you do number 9?
So using Bernoulli's principle again,
Yeah.
and it for both of them, it was the same process.
Yeah. I used the exact same equation for both of them. Like
Yeah.
I began with the original equation, but then since V1 and V2 were equal, I like canceled those out, and then I set everything equal to P2. And
That's
then
what I did.
Okay.
I did that too, and ended up with 2.75 times 10 to the 5th newtons over meters squared.
Yeah, that's what I have for the first one.
And then B, I ended up with 3.049 times 10 to the 5th
Yeah,
newtons over meters squared.
3.05, but yeah, that's the same as what I got.
Yeah. So.
All right, that's easy. This one actually was really easy, and a lot of it didn't have much math, so I
No.
like. I'm like, can the individual exercises be this easy, please?
So I was having help trying to find examples on the internet for the individual questions.
Yeah.
There's nothing.
I know. Okay, so my problem was that Friday night was when that like new Harry Potter movie came out, and my whole family wanted to go. So I was like working on it throughout the whole week, and then it came to Friday, and I had 2 problems left that I just couldn't figure out. And I had emailed him about both of them like 2 or 3 times. And so I went to like his online meeting, but there were a ton of people there. So he went over both of the problems, but briefly. And one of them worked when I went back to do it later, and the second one didn't. So I emailed him and I was like, dude, like, please, I can't figure this out. Like, I did what you told me and it was wrong. And then he like never responded. I kept trying to fix it. And then eventually he responds like during the movie and was like, hey, I gave you the wrong equation and the wrong thing. This is what you need to do. And at that point I was like, it's too late. And I had already submitted it and I didn't have time to redo all of the homework problems because that's what it does when you submit it. So I was like, whatever.
I couldn't figure out any of them.
They were hard.
Yeah.
Hard.
What was it? Yeah, it was ridiculous.
I had a really hard time with the like second Polly one where it was like just solving for a random, like it was like solve for C, and it was like just the weirdest way to ask a question, and then that one took me the longest, I think. One I never finished because he told me wrong. I'm like, you should owe me extra credit because I did my part.
Oh, you remember the group question
Yeah. Mm-hmm.
that you asked? So I asked him like, how are we supposed to put it in? And he's like, you just put it in.
You're like, okay, cool.
So I literally had to go find something that was, it ended up being the same.
Yeah. There you go.
And they plugged it in. So I was like, okay, I'm using this.
Yeah. You're like, sweet, I can do that. That's what I have a really hard time with in this class is like, I feel like a lot of it is simple, but it's not intuitive. Like, it's not like, oh, well, obviously I'm just going to do this. It's like so complicated to understand what they're even asking that by the time you understand it, you're like, well, what do I do now?
Yeah. My brother, he showed me one of his questions while he was doing the chemical engineering program.
Nothing.
But they worded it like this. So they used a movie figure, Godzilla. How much radiation would it take for Godzilla to become the size of a mountain? And they made it clear.
In my chemistry class, we would do questions like that. It'd be like, how many calories does so and so need to eat to be able to lift this with his telekinetic powers? Or and then in like the second chemistry, you do like nuclear reactions and nuclear chemistry. And so it'd be like, how many tons of TNT do you need to blow up the state of New York? Those are kind of fun though.
Those are awesome.
I have a new career. A new career experience I could try out. World domination. I like it when they make it those because it's like, first of all, like it's kind of a funny question and it's simple and you still get the idea and it's not overly complicated.
And you understand it.